In this video, we will discuss the properties of similar triangles and maybe some other shapes. And along the way, we might prove some triangles to be similar. So, problem number one. We can go ahead and make a similarity statement right now because angle A corresponds clearly with angle F. So I'll say triangle F. Let's see, angle B corresponds with angle D, so that'll be D, and that just leaves angle E. So that's important because that's going to allow us to know very easily which sides are corresponding. So for example, I know that AB corresponds with FD. Okay, so side AB corresponds with side FD. Side BC corresponds with DE. So BC goes with DE. And side AC corresponds with side FE. All right, so that is how the sides correspond. So let's do the sides first. We know that AB is 14, so this is 14, and we know that BC is 11, so this is 11. Okay, now in the other triangle, we know that DE is 5.5, so this is 5.5, and we know that EF is 6, so here's EF, and that is 6. So let's use the fact that corresponding sides are proportional to find side CA. So I'm just going to put an X right here. All right, so I know that X corresponds with the 6. See how they're both marked triple? So I'm going to make a fraction out of those, X over 6. And that should equal, let's see, I've got the 5.5, that's a double, and I've got the 11. So I can say 11 over 5.5. And then I simply cross multiply. So along this diagonal, I'm going to have 5.5x equals, and then 6 times 11, so that's 66. So then I just divide both sides by 5.5. Okay, so that's going to be 66 divided by 5.5. So that turns out to be 12. All right, now remember that is CA that I was just finding. So that is going to be 12. We also need to find side FD. So I'll call that Y. Okay, so let's make an equation out of that. Y is a single, 14 is a single, so that's Y over 14 equals. And I can still do, I can use the 11 and the 55, but since I did Y over 14, I need to do 5.5 over 11. Okay, you just got to do it in the same order both times. And again, I cross multiply, so this will be 11y is equal to whatever 14 times 5.5 is. So that's 77. So dividing both sides by 11, I discover that y is equal to 7. Now remember that y is df or fd, so that means fd is 7. So that's how you find the sides. Now let's go back and find the angles. All right, finding the angles is even easier than finding the sides, which was already pretty easy. Angle A is 52. Now that corresponds to angle F, so that also has to be 52. Now in addition to that, we know that angle D is 44. So angle D is 44. That corresponds with angle B, so that has to be 44. That gives us 2 out of 3 angles of each triangle, and we know that the angles have to add up to 180. So if I start with 180 and I subtract 44 and I subtract 52, that leaves me 84. So that means the missing angles are both 84. So let's see. So that means angle B, well, that's 44 degrees. The measure of angle C, that's 84 degrees. The measure of angle E, that was 84 degrees. And the measure of angle F, that's 52 degrees. Okay, on problem number 2, we are given that triangle FGH is similar to triangle JKL, and we're given some sides, and we're asked to find some missing sides. I am going to sketch the picture first, because why not? So this will be my triangle FGH, and then this will be my triangle JKL. Okay. And FG is 10. So this is 10. And JK is 12. So that is 12. GH is 14. And JL is 22. All right, so we need to find FH, and I'm going to call that X in my picture. So FH, I'll call that X. And we need to find KL, and I will call that Y. Okay, so let me start by finding X. So that means I need an equation involving X. So I will do X over 22. And now I need a pair of all numbers. So I will do 10 over 12. Okay, so that's X over, whoops. So this is 5 over 6. So I cross multiply and I get 6x is equal to whatever 5 times 22 is. 110. Then I'm just going to divide by 6. Okay, so I'm getting this decimal. They don't give me permission to have a decimal. We don't have permission to round. So I better leave it as a fraction. 55 over 3. Okay. So that's FH, don't forget. So FH is 55 over 3. Okay, now I need to find KL. So for KL, that's going to be Y. So I'm going to do Y over 14. And if I do Y over 14, then I must do 12 over 10. Okay, 12 over 10. All right, so that's 6 over 5. So when I cross multiply, that's 5y is equal to whatever is 14 times 6. So that's 84. Okay, so 84 divided by 5. So that's 16.8. Okay, now keep in mind that this was KL. So, you know what, maybe I'll write it off to the side. So we found out that FH is 55 over 3, and KL is 16.8. I'm allowed to write this as a decimal because it's a short decimal. It doesn't go off the calculator screen. I don't have to round it. FH, I had to write it as a fraction because the decimal went off the calculator screen. This proportion is set up incorrectly. What is wrong with it? Let's see. The problem is going to be the 10. Since we are using these parallel sides here, we're not doing the side splitter theorem, we have to use these triangles separately. So I need to draw the small triangle and the large triangle separately. Okay, so here is the small triangle. Let's see. And now here comes the large triangle. Okay, let's do a different color this time. Well, I guess I'll draw it first. All right, so I've got the small triangle and I've got the large triangle. Hopefully you can see that on the small triangle we have the 4 here and the 6 here and the 3 here. Now the large triangle is slightly trickier. See this side over here we have the x. Now this side right here is 4 plus 10. So this side will be 14. Notice that 10 is not any of the sides. It's not the side of a small triangle and it's not the side of a big triangle. It's just a portion of the side of the large triangle. So that's what's wrong with it. 10 is not the side of any triangle. So as far as correcting it, if I want to find x, I will do x over 3, all right? So I'm doing like blue over red. So I need to do blue over red again as I do 14 over 4, all right? So it should be 14 and not 10. And then you cross multiply. So along this diagonal, I get 4x. And the other diagonal, I have 3 times 14, which is 42. And then I have to divide by 4. So that's 10.5. In problem number 4, I need to find x and y, and I'm going to find those in 2 different ways. If I want to find y, the easiest thing to do is to use the side splitter theorem. Okay, so I can have this pair. When you have the parallel sides of these triangles, you can make these segments proportional. Okay, it's called the side splitter theorem. So I can do, for example, 5 over y, all right, and that should equal 3 over 12. This will not work with the parallel sides. It only works with the sides, okay, not the bases of the triangle. So this is going to be 5 over y is equal to 1 over 4. So that means y, that's this diagonal, is going to equal 20, the other diagonal. So that's one of the things. Now, when you're dealing with the parallel sides, you cannot use the side splitter theorem. You need to use the small triangle and the large triangle. You need to draw them separately. So that's what I'm going to do. I'm going to draw the triangles separately. So, for example, here's the larger triangle. Okay. All right, there's the larger triangle. And then here comes the smaller triangle. Let me erase that real quick. All right, and here's the smaller triangle. Going like this. Okay. Now, for the smaller triangle, this is y, and this is x, and this is 12. Okay. Now, for the larger triangle, this side is 18. All right, and here's where the mistakes usually happen, but this side is 15. All right, 3 plus 12. So this side is 15. Okay, and this side would be 5 plus y. Or I could have said y plus 5. Okay, but I already found y, so I don't need to worry about that. Now I am finding x. So I see the x right there, so I will do x over 18 is equal to, and then I'll use the 12 and the 15. So 12 over 15. Okay, this reduces to 4 over 5. So when I cross multiply, I'm going to have 5x equals whatever 4 times 18 is. Okay, that's 72. And then I need to divide by 5. And that's 14.4. Number 5, Carl is 6 feet tall. When he stands 12 feet away from a flagpole, the tip of his shadow is in the same spot as the tip of the flagpole's shadow, 8 feet behind him. How tall is the flagpole? All right, so in the end, we're looking for the height of this flagpole. When you have overlapping triangles like this, really the best thing to do is to draw the triangles separately. So I'm going to make one triangle out of Carl's tiny body and his shadow. Okay, so I have this triangle. And then at the same time, I'm going to make another triangle out of the big triangle involving the flag. Uh-oh, I missed. Let me try that again. All right, so I have the small triangle and the large triangle. So looking at the small triangle, I can see that this is 6 feet and this is 8 feet. Okay, and remember, this is the X, the flagpole. So here's where you have to be careful. The bottom side right here is not 12, it's 8 plus 12, it's 20. So when I go to find the height of the flagpole, I'm going to do x over 6, all right, x over 6, and that should equal 20 over 8. So x over 6 reduces down to, let's see, both of these are divisible by 4, so 5 over 2. And then I cross multiply. So I have 2x is equal to 30. And when I divide by 2, I get x is equal to 15 feet. So that will be the height of the flagpole. The key is to draw the triangles separately. Okay, before we start problem number 6, you need to understand how the ratio of lengths compares to the ratio of areas. So for example, imagine that the ratio of lengths is x to y. Then the ratio of areas will be x squared to y squared. So in this case, we're given the perimeter of parallelogram A and the perimeter of parallelogram B. So the ratio of those lengths is 28 to 56. Now we need to write that in reduced form, of course. So treat it as a fraction and think 28 over 56 as a fraction. And that reduces down to 1/2. So that means the ratio of lengths is 1 to 2. Okay? So that's like the x and the y. Now the ratio of areas will be x squared to y squared. So that will be 1 to 4. Okay, so this is like the length scale factor, and this is like the area scale factor. So now I need to find the value of x. So I have the x and I have the 16. Okay, so I'm going to go x over 16. All right, so this is small over big. And I'm going to set that equal to the scale factor in the ratio of small over big. So that's the equation, and I can simply cross multiply. So that will give me 2x is equal to 16, and when I divide by 2, I get x is equal to 8. All right, now, if the area of the parallelogram, of parallelogram B is 144, what is the area of parallelogram A? Okay, so the area of parallelogram B, so this is the large area. So if I go small over large is equal to small over large, okay, that's how my proportion will work. Then the area of parallelogram A will be the small area. So I'll let that be y. I'll let y be the small area. So I'll have y over 144. Okay, that's the small over large area. Now because I'm talking about area, then I'm going to set that equal to the area scale factor in the form small over large, so 1 over 4. So if you're finding a length, use the length scale factor. If you're finding an area, use the area scale factor. If I cross multiply, that'll be 4y is equal to 144. Then I have to divide both sides by 4. So what is 144 divided by 4? 36. So y is 36. 36 square units. All right, so that will be the area of parallelogram A. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.